long enough for people that might show up a little bit late. But welcome to class. Today and the rest of the week we're going to be talking about section 2.6 and 2.7. Those are the last two sections of chapter 2. And today the title is Other Equations. So it's really sort of a collection of different types of things that will show up later on again in your math careers or in applications of the stuff from college algebra. So they're important equations, but they're kind of just sort of maybe loosely connected to one another. So we're going to sort of tie up some loose ends here with section 2.6. And then in 2.7, we're not going to talk about equations, but inequalities. So I'll remind you a little bit about inequalities and absolute values today. And then on Friday, we'll hit some more difficult ones. Okay, and then as usual, we'll start with our learning objectives for today. This is section 2.6 again. The title again is Other Equations. And the three types of equations that we'll work on are solving equations that involve rational exponents. So remember, a rational exponent is something like, x to the 2/3, right? So it's an integer over an integer. And they could be positive or negative, but that's what a rational exponent is. And we'd like to solve equations or solve for the x in some equation where something like x to the 2/3 shows up. And we've already seen some examples of this sort of thing when we've dealt with square roots where we square both sides to cancel things out. But we'll talk about it a little more systematically, and I'll give you some examples of the kind of thing that show up in infinity. These are probably the easiest examples in infinity. You should be able to dispense with these pretty quickly in homework section 2.6. And then we also have here as an objective solve radical equations. But if you remember from our review, rational exponents and radicals are sort of two sides of the same coin. So they're just two different ways of expressing sort of the same facts. And I'll remind you of that. And then we'll go through and solve some radical equations. At the end of all of it, I'll summarize sort of the how-to, but I won't show you the how-to until we've gone through a couple of examples and sort of summarize the details, because there's like 5 steps on it, and it's best to sort of see some examples. But really, these two first learning objectives are essentially the same, okay? So rational exponents and radical equations, they're going to be solved in the same way. Then we'll move on to the third thing from today, which is absolute value equations. So I'll remind you what an absolute value is, and then we'll talk about sort of the details. There's sort of a plus or minus thing that happens with absolute value equations, and we'll talk about that near the end of class. And then hopefully the last 10 minutes of class will be over sort of the 3 hardest problems in infinity. So there are 3 problems. I think it's questions, let me see, 8, 9, and 10 from the homework that are pretty difficult, okay? And they require you to do a substitution. There's no learning objective here related to those, but those of you going on to calculus will see this trick a few times, and so it's a good one to just know, right? But if there's no specific learning objective related to that. And then as usual, I'll leave it up just for a second here, and then we'll move on to the next slide in case somebody wants to ask a question or they're just copying down for their notes the learning objective. All right, great. So this is just a quick reminder of the review section. Remember, a rational exponent is just something like the following. It's a number a raised to a fraction, m over n. Typically, m and n are just integers. And there are multiple ways of thinking about this. Just because of the way that exponents work, remember, if you have something like a to the x raised to a to the y, it's the same thing as a to the x times y. That's just one of the properties of exponents that we should be familiar with. And here, if we take m over n, you can think about it as m times 1 over n, because dividing by n is the same thing as multiplying by that reciprocal. So we can rewrite this m over n as a to the 1 over n, all raised to the power of n. And that sometimes is important, right? We might want to rewrite something in that format, just depends on the setting. But we can also rewrite it in a slightly different way, because 1 over n times m is the same thing as m times 1 over m, so we could rewrite it as a to the m, and then all raised to the power of 1 over n. Okay, and that just follows from this fact about exponents. Okay, so it's just one way to rewrite a rational exponent, or two ways to rewrite a rational exponent. And then as a reminder, if you have an nth root, the nth root of something, right, is the same thing as raising to the power of 1 over n. So here, a to the m raised to the power of 1 over n is the same thing as the nth root of m. I'm sorry, a to the m, where this a to the m is underneath the radical, the radicand. Right? Or if you'd like, we could also just say, okay, take the nth root of a and then raise it to the power of m. So that's what this last piece is. So basically, the take-home message here is that all of these expressions here denote the exact same thing, okay? And anytime that you're going to be dealing with a radical equation, it's the same steps that you would deal with a rational equation, right, when you're dealing with these rational exponents. And really the key here with all of these is that you're going to want to undo a rational exponent, like this guy up here, okay? And the way that you'll undo this exponent is you'll raise both sides of the equation to the same power, and the power that you'll raise it to is the reciprocal of what you're seeing here. So here, if we wanted to undo the 2/3, we would raise both sides of the equation to the power of 3/2. That's just the reciprocal of this. And the reason why is that if we do that, we get x to the power of 2/3 times 3 over 2. So that's that property I was mentioning before. If you raise an exponent to an exponent, notice the 3 cancels with the 3. The 2 cancels with the 2. You get x to the power of 1, which is just x. Okay? So to undo a rational exponent, you raise to the power of its reciprocal. Like, let me give you another example here. If you were looking at the square root of x, remember the square root of x is the same thing as x to the power of 1/2. So to undo this, you would raise both sides to the power of the reciprocal, which is 2 over 1, or just 2. And you'd get back x, okay? So you just raise to the power of the reciprocal to undo that rational exponent. And remember, there are many ways that you can write out a rational exponent, including something with a radical. Now, to be a little more specific about what we mean by a radical equation is just any equation where you have a radical, right, a square root or a cube root or an nth root showing up, something like this. And inside of the equation, inside of that radical, there's a variable like x or y or t or something like that, right? So any equation that contains a variable inside the radical is called a radical equation, okay? And we'll be interested in isolating that thing that's underneath the square root or the nth root or whatever it is. Now, this is where it's going to become extremely important that you actually check your answer. So previously, we've been sort of stressing, and the book has been stressing that you check your answer. But here, it's going to be incredibly important that you check your answer because often you'll get down to an answer, and if you try to plug it back into the original expression, you're going to get the square root of a negative number, or you might end up dividing by 0 or something like that. So for these questions, it's really important that you go back and check your work. Donald, do you have a question? If you do, post it in the chat. Or get on mic if you have a question.
No, I don't have one.
Oh, okay. I just saw your hand go up on the thing. Okay, so that's a radical equation. Okay, so radical equations and rational exponents are done the same way. And what I want to do now are just some examples of the type of thing you'll see in Infinity. So these are like the first 4 or 5 questions in Infinity are similar to this sort of stuff. Okay. So here's the first one. We're going to talk about how you solve the third root of x is equal to 5. And I'm going to go through this one probably a lot slower than I'll go through other examples today, just because I want to illustrate sort of the technique here. And if you know how to undo a cube root, you can go ahead and do that. But I'm going to rewrite this as a rational exponent first. Okay. So the third root is the same thing as x to the 1/3. Okay, that's just from that first slide that we had. We're rewriting a radical as a rational exponent. And now, if I want to undo this 1/3, what should I raise both sides of the equation to? So what number? Post that in the chat, I guess, is what I'm asking you to do. what number should we post here up in the exponents in order to cancel out that 1/3? Okay, it's a 3, and I think I've seen a couple people write it as 3 over 1, right? So it's just the reciprocal. 3 over 1 is just 3. So we'd raise this side to the power of 3 and this side to the power of 3. The left-hand side, 1/3 times 3 is just 1, so you're going to be left with x on its own. And the right-hand side, what do we get for 5 to the power of 3? Okay, Alan, Destiny's got it there. So it's 125. So that's just 5 times 5 times 5, 125. And I'm going to box my answer, but remember, we really should go back and actually check our work, right? In a calculator, or just, verify that the third root of 125 is indeed equal to 5. Okay? But again, the goal here, you could have jumped straight from here if you just see that the third root can be undone by 3. You could raise both sides to the power of 3. But here we're rewriting it specifically as a rational exponent, so you can see that we're really just taking to the power of the reciprocal. Okay, so, and again, this is a radical equation because there's an unknown underneath the square root here. So let's do another example. Again, these are probably like the simplest ones that you're going to see in the homework assignment, so we're going to try and go through these a little more quickly so we can save some time for the more intricate ones at the end of class today. So the next one is going to look like this. The square root of x plus 5 is equal to 7. So now it's not just x underneath the radical, but an entire expression. And in this case, what does the square root give us as an exponent? So what exponent do we get for the square root? Okay, yeah, so it's a 1/2, right? Anytime this is a missing from here, we think about it as a 2. So this is x plus 5 to the 1/2. And again, you can just square both sides at this point. If you can see that to undo the square root, you could just go right to squaring both sides. But I wanted to point out here that what we'll do is square this side and we'll square that side, okay? Because here we'll have a 1/2, the reciprocal of 1/2 is 2. Okay, so that's how we'll end up canceling the 1/2 and 2. Okay, so what do we get on the next line down, right? So in the chat here, what happens to the 1/2 and the 2, and what happens to this right-hand side of the equation? What equation should we get on the next line? Again, this is the sort of thing you should include in your class notes and your supporting work for the homework. Okay, so yeah, everybody sees here that like the goal is to get rid of the exponents. So on this side, we just get our good x plus 5, and on the right-hand side, we get 49, okay? And so here we've just sort of raised to the reciprocal of the exponent, and then now we can identify the x on its own. We're going to subtract 5 from both sides. Subtracting 5 from both sides, we get 44. And again, we should check, right? So you might have been able to just look at this and see, well, yeah, of course, 44 plus 5 is 49, and the square root of 49 is 7. So you might have been able to just look at this and guess your answer. But what we're seeing here are the sort of the systematic steps to get down to an answer, right? Because it's not always going to be as simple as this. The other step that you may have to do is you'll notice that the square root was already sort of isolated on its own on one side of the equation. There are examples where it won't be. So you'll have to sort of first solve for the radical in order to do this trick of sort of getting rid of the exponent, okay? So let's do one more example along those lines, and we can sort of see what we get there. Okay. So this is question number 3. And I guess I'm lying. You don't have to isolate the radical here. This one is already isolated for you as well. But this is a good example because you get 2 solutions instead of 1. So here we'll look at the square root of x minus 19 is equal to x minus 1. And the nice thing in this case, I don't know if it's a nice thing, but the difference between this one and the previous one is that you can't just guess the answer here. I don't think many of us can just see exactly what the 2 answers are. But we can go through and do the same sort of thing that we did before. And this time I'm not going to rewrite this square root as a rational exponent. I'm just going to sort of write down what I would expect you to write down on an exam or something like that. If you want to undo a square root, you just simply square this side of the equation. And if you do something to one side of the equation, you better do it to the other side as well. Okay? Yeah, and so Jordan here is pointing out that here we get just 10x minus 19, and on the other side we get x minus 1 squared. Now it's tempting at this point, and a lot of students make the mistake of putting plus or minus here. But remember, you only put the plus or minus if you're taking the square root of both sides, and not if you're squaring both sides. If you're squaring both sides, there's no need for your two solutions to pop up here. You're just going to square both sides. So let's go ahead and FOIL this side out. What do we get when we multiply this out? So we should recognize this is a quadratic, and we're going to want to like multiply everything out and move to one side of the equation. So what do we get on this right-hand side when we FOIL out the x minus 1 squared? So again, what I'm saying is we get 10x minus 19 here, but what do we get on this side? Okay, yeah, so it's going to be x minus 1 times x minus 1. So the first is going to give us an x squared. Then there's going to be a negative x and a negative x. That's the inner and the outer term. So that's a minus 2x. And then finally, you have a negative 1 times a negative 1, which gives you positive 1. Okay? So that right-hand side, when you FOIL it out, is x squared minus 2x plus 1. Okay. And now, at this point, if you didn't recognize that it was a quadratic, you should now, because there's an x squared term here. And anytime there's this x squared term, we can't just go ahead and like solve for the x. We're going to have to move everything to one side of the equation and see if we can factor. If we can't factor, we can use the quadratic formula. So I'm going to move everything to the right-hand side so that it's 0 on this side. And as soon as you move the 10x and the negative 19 to the right-hand side, chime in with the quadratic you get on the right-hand side here. So let me know what you guys get for the right-hand side of this new equation. Okay, so just as a hint here, the x squared is on its own, right? There's just x squared, so that x squared stays there. And then this 19, this negative 19, if we want to move it to that side of the equation, we add 19 to both sides. There's already a 1 over here, so adding 19 to both sides, this 19 cancels out. The negative 19 cancels out, we're left with a 20 over there. And then here, to get this 10x to the other side, we subtract 10 from both sides. And so negative 2x minus 10x, that's negative 12x. Okay, and then at this point, we try to factor if we can. If we can't factor, then we use the quadratic formula or we complete the square. In this case, it's something like an x and an x because this is a 1 out here. And we're going to need two numbers that multiply together to give us 20, but add together to give us negative 12. Because this is negative and this one's positive, that means both of these are negative. Well, what are the two negative numbers here? Okay, everybody's in the chat is already sort of posting in what those two negative numbers are. It's 2 and 10, right? So negative 2 times negative 10 is 20. Negative times a negative is a positive. And negative 2 plus negative 10 is negative 12. Okay, so at this point, we can now go back and use our zero factor property. So this is the same thing that we do for all of our quadratics. And we just say that if we have two numbers multiplied together, the only way we're going to get 0 is if either the first number is 0 or the second number was 0. Right? If they're both non-zero and we multiply them together, we're not going to get 0. So one of these two things had to happen. And what are the two answers we get here? Go ahead and solve for x. What two values of x do we get? Okay, so 2 and 10, right? So adding 2 to this side, we get 2. Adding 10 to this side, we get 10. And before I box my answer, you really should go back and check to make sure you're not taking the square root of a negative or you're possibly not dividing by 0, right? There's no division here, so we don't have to worry about that. But we should go in and check our work. So in this case, if we plug in a 2 into our original equation, remember there was no square in our original equation, we get 10 times 2, that's 20. And 20 minus 19, well, that's 1. The square root of 1 is just 1. Okay, on the right-hand side, we get 2 minus 1, which is just 1. So that works out, okay? So 2, we plug in, and we don't get any square roots of negatives. We don't have to throw that guy out. For the 10 as well here, we plug in the 10, we get 10 times 10, that's 100. We subtract the 19, we get 81. The square root of 81 is 9. And on this side, we get 10 minus 1, that's 9. So we see that we've got another solution here with x equals 10. Well, anytime there's a radical or a fraction, you should check your work, right? Because you may have to throw out your answer. In this case, you didn't. You have 2 answers. So it was really a quadratic in disguise. So let's now talk a little bit more about the exact steps, okay? So this was sort of the examples that I had mentioned to you. Let's talk about the details of the steps, about how you would solve one of these radical equations, okay? So what do? Well, something that we didn't have to do, I mentioned that we were going to do it, but we didn't have to do that for any of our answers here, is we may have to actually isolate the radical expression on one side of the equal sign before we do anything. So this last example we were looking at here, the radical was already isolated on its own on one side, right? It may be the case that you don't have the radical on its own, so you may have to actually solve for that radical on its own, okay? So, and then you put everything else on the other side of the equation, okay? You just get that radical on its own. If the radical is a square root, you just square both sides. If it's a cube root, then you take the power of 3 to both sides. And if it's an nth root, you just take a power of n on both sides. This is exactly what we were talking about before. You just multiply, or you raise both sides to the power of the reciprocal, right? And they're just sort of spelling that out in a little more detail here. But you get that radical on its own, like this one, right? And then you square both sides, or you raise to the power of the reciprocal. And then you try to solve it, right? And in the last example, we got to this quadratic that we ended up with, and we ended up solving it. So that was good. However, it's not always that simple. And the next step in the how-to is just sort of reminding you of the fact that it's not always that simple. You may still have a radical in your expression. You may have squared both sides, but because of the way it's set up in the most complicated version of these sort of problems, you may have another radical showing up. So what you do is you go back and you just isolate the new radical and you undo it. And you isolate the new radical and you undo it. And you just keep repeating steps 1 and 2 until all the radicals are gone. And then finally, you just solve the remaining equation. And then most importantly, you check. Right? You have to check to see that your answer was a solution to the original equation. So again, it's a lot like just isolating an x, but now you're isolating the radical and then undoing the exponent. And again, if somebody's following along writing this down, I'm going to pause for a moment just because there's a lot of sort of stuff on the board. And I guess I should just say, if you have enough where you've copied it down, give me a thumbs up, and then when we have enough people sort of happy with this part here, we'll move on to the next section. Okay, so it looks like we've got a good deal of students going through and doing that. So we have enough, we're giving you enough time. So if you need to, you can come back and check it out, right? So the next thing we're going to talk about are the absolute value equations. That's that third objective we had in the learning objectives. And before you sort of read through what I have here, let's go through and remind ourselves of the absolute value, right? So what exactly is the absolute value? And you know, you can read the definition in the book, but I think it can confuse people often. So let's just do some examples because it's not that complicated once you see the examples. So I'm going to ask you a couple of examples here. What's the absolute value of 10? Just chime in the chat if you know the answer. Absolute value of 10 is just what? It's just 10. And that's because 10 is positive. If I had 2.1, the absolute value would just be 2.1. Yeah, I mean, anytime something's positive, the absolute value just gives you back that number. What it does differently is if you give it a negative number. So like, let's say you were to take the absolute value of -9. What do you get there? 9. So if you plug in a negative, the absolute value gives you back the positive, right? So it's always going to give you back whatever the positive version sort of that number is, and not the negative. And just one more example, you know, the absolute value of -1.3 is just 1.3. Okay. So absolute values always give you a positive value. Okay. And before I go on to that slide again, I also want to point out something that shows up there as well, and that's an inequality. In section 2.7 on Friday, we're going to talk about inequalities in a lot more detail, but I'm going to remind you of sort of 3 things that show up here on the next slide. On the next slide, we're going to have a variable c, and we're going to write 3 inequalities, or I guess 2 inequalities in one equation. So the equation is c equals 0, and then 2 inequalities that look like this. And I want to talk about these before that slide comes up, because students will often struggle, especially in an introductory algebra class like this, with remembering how this works, okay? So just remember that with an inequality, sort of the larger side, right, if you think about this as like a mouse, if this is like an elementary school class or something, the larger side, right, the mouse here is eating the bigger of the numbers. So when you write down an expression like this means that c is bigger than 0. In other words, c is positive. Okay, so this is saying c is positive. This one here is saying c is just 0. Okay, and 0 has sort of the unique feature that positive 0 is the same thing as negative 0. It's the only number where the positive and negative are exactly the same. And then finally, this one here is saying that the 0 is the bigger of the 2 numbers. In other words, c is less than 0. In other words, to the left of 0 on the number line, this says c is negative. So this says c is positive, this says c is 0, and this says c is negative. And just keep that in mind as we go on to the next section, 2.7, and also this next slide. Okay, so what do we have in this slide? Again, this section was titled Other Equations, and this is a different type of equation rather than the radical equations that we were doing before. These are absolute value equations. And an absolute value equation is just something that looks like this form. The absolute value of ax plus b is equal to c. And here the a, the b, and the c are just like in the quadratic equation, where they're just fixed numbers, right? So typically people will, you know, in an affinity or something like this, when you're doing a homework problem or a quiz, will give you the values of a, b, and c. And you're supposed to try and find a value of x that makes that equation true. So there are 3 possibilities. The first one is sort of the simplest. If you rewrite your equation and you isolate the absolute value, and you find that the absolute value of something is negative, right? So this is that c is smaller than 0. If it's negative, then there's no solution. And that's just because there's no way the absolute value of something could possibly give you something negative, right? That's just not the definition of the absolute value. And so if you see that right-hand side is negative, you just automatically stop and say there's no solution. Okay, and then the other 2 possibilities are that there's 1 solution or 2 solutions, but they're sort of taken care of in the same way. And the way that they're taken care of is with this down here. So let's say you have this absolute value equation. What you want to do is you want to isolate the absolute value expression on one side of the equation. So it may not be as simple as this. And the first, I think one of the examples I give you is not as simple as this. But first you want to isolate that absolute value. And then you realize that there's 2 possibilities. That absolute value of ax plus b is either equal to c, or the absolute value, the ax plus b is equal to negative c. Because if c is positive, the only way that you can get c from an absolute value is either from c itself or from negative c. So you jump basically to 2 equations, the same way that you did using the 0 factor property, but you're just going to get one for positive c, one for negative c. Okay. Now, why do you get 1 solution in one case and 2 in another? Well, if the c is 0, you're going to get the same equation. Ax plus b is equal to positive 0, and ax plus b is equal to negative 0. So there'll only be 1 solution. However, if the c is positive, you'll get 2 different solutions, right? Ax plus b is equal to that positive c, and ax plus b is equal to the negative c. So in other words, to deal with that absolute value in an equation, you just have to know that you jump to a positive and a negative, right? You get two equations at some point. So let's do a couple of examples of that. Okay, so this is example number 4. And here we're going to look at x plus 2 is equal to 5. Okay? And so we're looking at x plus 2 is equal to 5. And we're going to follow that step, right? So in this case, the c is 5. And what that means is that we get two possibilities. Either x plus 2 was equal to 5, or x plus 2 was equal to negative 5. Because that's the only way the absolute value of x plus 2 would be equal to 5, if it was either 5 or negative 5. Those are the only two things that give you an absolute value of 5. So you break it up that way, and then you just solve each one of these equations individually. So chime in when you get a chance with the two solutions here. What do you get for your solution? Okay, so this one over here, we're subtracting 2 from both sides, so we get x is equal to 3. Here we're subtracting 2 from both sides, so we get x is equal to negative 7. So negative 5 minus 2 is negative 7. And you can always check your answers, right? So here, 3 plus 2 is 5. The absolute value of 5 is 5. So this is good. This one is negative 7 plus 2. Well, that's negative 5. The absolute value of negative 5 is 5. So this one's good as well. Okay? This is an example where you get two solutions. Let's do an example now that looks a little bit different than this. This is example number 5. And here, we're going to look at the absolute value of x minus 1 plus 3 is equal to 2. And this is where we have to do that first step, right? And you'd have to do this if it was a radical as well. We need to isolate that absolute value. So what should we subtract or add to both sides of the equation to isolate that absolute value on its own? Okay, so everybody has negative 3 here. So we're adding negative 3 to both sides, or just subtracting 3, right? So if we subtract 3 from both sides, you get absolute value of x minus 1 is equal to negative 1. And we don't have to do any more work here. We can just write down the answer. What is the answer in this case? Should we get? Not 0. So if we plug in 0, then 0 minus 1 is negative 1. The absolute value of negative 1 is 1, and that's not a true equation. So x equals 0 is not the solution. Neither is x equals 1. What is going on here? We don't go to two separate equations like we did up here. What do we write down? Angelique has the right answer here. So it's no solution. And we don't have to show any more work from here. We just say no solution. And the reason there's no solution is just that there's no way the absolute value of anything could be negative. Here they're asking us to find the absolute value of x minus 1 and we get back negative 1. So no, there's no solution. And we just stop the problem right there. And that was that first sort of bullet point, right? That if you try to solve for this ax plus b absolute value and it's negative, you just say no solution, okay? So there's your answer there. And don't be confused here. You shouldn't go to like x minus 1 is equal to plus 1 and x minus 1 is equal to negative 1 because that's not going to get you what you want, right? What you want to do here is just say no solution. Okay, and then there was a third possibility. So this was a two solution example. This was a no solution example. It may be the case that you have one solution. So let me give you an example of something like that. This is question number 5. And here we're going to look at the absolute value of x minus 1 is equal to 0. Let's say you solve for the absolute value, and instead of getting a positive or a negative number, you get 0. So if it was negative, you'd say no solution. If it was positive, you'd do this plus or minus thing. And here you can try the plus or minus thing, but remember, negative 0 is just 0, and positive 0 is just 0. Or another way to think about it is the only way you're going to get an absolute value of 0 is if x minus 1 itself was 0. Right? That's the only way the absolute value will be equal to 0. So here, when it's equal to 0, you just get one solution. You add 1 to both sides. There it is, x is equal to 1. Okay? So that's just illustrating the possibilities that you can get, either one solution, no solution, or two solutions. Okay, so those were our examples related to the learning objectives. Now, what I would like to do sort of in the last 15 minutes or so is talk about the more difficult questions from Edfinity. So we've already talked about, let me just remind you of the learning objectives. We've talked about rational exponents and radical equations and how to solve those. And we just talked about what we mean by absolute value equations and how to solve those. So we've gone through the 3 learning objectives. But as I mentioned before, there are sort of 3 or 4 questions in Edfinity that don't adhere to these learning objectives. And again, you'll see them if you're going to take calculus, you'll see these sort of tricks showing up. So the first one is something that I had to remove from a previous homework assignment. I think it was section 2.3. If you did it early enough, you got down to a quadratic. We hadn't talked about quadratics yet, so I just removed it. If you waited on that assignment, you didn't see anything like that. But here's an example of something like that, okay? Remember, we were solving these rational equations that look like this, right? A rational expression is just a polynomial divided by a polynomial. And we were interested in solving for x, right? And I'm going to go through this example one time because I think it's a really good example. But the point here is just that sometimes when you clear out those denominators, instead of just getting a regular old linear equation that you can solve, there are many examples where that was the case, but many times you're not going to get just a linear equation, you're going to instead get a quadratic. If you end up at something that's a quadratic, you should try to use factoring or the quadratic equation or the stuff from 2.5 in order to solve the equation. And this is an example where that happens. So let me put this up on the board, and then we'll go through the steps of solving this one. So this is negative 4x over x minus 1 plus 4 over x plus 1 is equal to negative 8 over x squared plus 1. Okay, and I'm going to jump back to my board so we have a little more space to see all the details. Now, what we want to do with this problem is get rid of the denominators, okay? So we want to multiply both sides of this equation by the least common denominator. So somebody tell me what the least common denominator in this case is. What should we multiply both sides by in order to clear out all of those fractions? Okay, so sorry. Yeah, I wrote this should be x squared minus 1. That was a typo in my notes there. Okay, now I see why not a lot of you were chiming in with the common denominator because it'd be a lot bigger. Okay, so it's x squared minus 1 on the right-hand side. Sorry, guys. This makes the other one would have been a way harder problem. And at this point, I think a lot of you are chiming in with the right answer. This factors into x plus 1 times x minus 1. So the least common denominator in this case is going to be x plus 1 times x minus 1. So multiply this side by x plus 1 and this side times x plus 1 times x minus 1. Okay? And that's again because this denominator here factors into x plus 1 times x minus 1. I had a plus 1 previously, but it should be a minus 1. I think that's what it said in the, I might have had a typo error. Yeah, so here it said minus 1 down there in that denominator, x squared minus 1. Okay, so coming back, we'll have to multiply these to both of these terms. Here, the x minus 1s will cancel each other out, and we're going to be left with negative 4x times the x plus 1, right? So the x plus 1 here multiplies by the negative 4x, and then the x minus 1 cancels with this one. When I multiply it to this one here, in the second case, the x plus 1s cancel, and I'm left with 4 times the x minus 1. Okay, and on the right-hand side, what am I left with when I multiply by the x plus 1 times x minus 1? What should this be equal to? Okay, yeah, so this guy is just the same thing as x plus 1 times x minus 1. So on the right-hand side, we get negative 8. Okay, so now let's multiply this side out. Here we're going to get negative 4x squared. So I'm just multiplying the negative 4x times the x. And then negative 4x times 1 is minus 4x. So that's this term, just distributing. Now we'll distribute the 4, so we get plus 4x and then minus 4. So 4 times negative 1 is minus 4. And this is still all equal to negative 8. Okay, so simplify the left-hand side over here. What quadratic do we get on the left-hand side after we simplify? Okay, yeah, so the negative 4x and the 4x cancel each other out. We're left with negative 4x squared minus 4 is equal to negative 8. Now, it's tempting to move everything to one side and then try and apply the quadratic formula, but there's no x term, right? This x term disappeared. So instead, what we can do is just isolate the x and then use the square root of both sides to get rid of the square. Okay, so that means that we need to add 4 to both sides of the equation. So go ahead and add 4 to both sides of the equation, and when you have it, write down in the chat what the new equation is. So you're adding 4 to both sides. Okay, yeah, so be careful, right? When you add 4 here, that cancels out with the negative 4. And then here, it's a little bit confusing. Negative 8 plus 4 is negative 4. So this is negative 4x squared is equal to negative 4. Now we divide by the negative 4 on both sides. That cancels it out on this side, and we're left with x squared is equal to 1. Now we can go through and take the square root of both sides. But remember, when we take the square root of both sides, we have to put the plus or minus. So here we'll get x is equal to plus or minus 1. And I'm not going to box my answer here, right? So again, what does this mean? This means that either x is equal to 1 or x is equal to negative 1. What's the issue? What is the problem? This is not the solution. Neither 1 nor negative 1 are solutions to this equation. So in infinity, you'd have to write down no solution. But the question I have for you guys is why? What is the issue here? Okay, so try to plug it back into the original, right? What happens when you plug it into the original? There's an issue. Yeah, so Dalton has here. If I plug in 1 into this, I get 0 in the denominator. If I plug in negative 1 into this, I get 0 in the denominator. So these are both extraneous solutions, and we should just say there's no solution to this problem. So again, you need to be really careful with these problems from this section, that you go back and you actually check that it's a solution to the original equation, because you could divide by 0, or you could be taking the square root of a negative. Okay? So here we did all of that work to get down to the fact that, well, it's not actually a solution to the original equation. And so there would be no solution here. Okay, so just coming back to that one, that's one where you'll get a quadratic. Now let me finish up with one last example in these last 5 minutes of probably the hardest question in infinity. And there's sort of 3 of them, right? It says, I guess, question 8, 9, and 10. I have it written down here, so I'll write that on the board so you can see that. So this is similar to homework question 8, 9, and 10. So each one of these questions in infinity requires a similar sort of trick that you're going to see right now. Alan, it depends on the question. I would just pay attention to what the question is asking you to input. Sometimes it's D&E, sometimes it's no solution. Just depends on sort of the statement of the question. Okay, so here they're going to ask you to solve something like this. X to the fourth minus 37 x squared plus 36 is equal to 0. And you look at that and you say, x to the fourth. We don't have any techniques yet to deal with something like x to the fourth. But I'm going to give you one right now. And this is going to work anytime that you see a variable and its square in the formula, right? So here I see x squared, and if I square x squared, I get x to the fourth. Let me write that down here. If I square x squared, I get x to the fourth. And that's the key in this problem to solving for x, okay? To realize that the square shows up. And that's the same thing that's going to happen in 9 and 10, different substitution. Okay, so you'll make a substitution and you'll change this into something that is simpler. Now, like I said, the square of this is equal to x to the fourth. So what I'm going to do is I'm just going to let t be equal to that x squared. And again, that's because when I square that, I get x to the fourth, okay? Now, let's see what happens when I convert this whole equation over to t. This x to the fourth is really the same thing as t squared. This x squared is really just the same thing as t. And this 36 doesn't have an x or a t in it, so we could just write it as 36. And you can see that it's a lot simpler in this format. And the reason I knew to convert over to t is because I've seen x squared and the square of x squared here. What you'll do for 9 and 10 are different. Okay, so now we can factor this. If we can factor a quadratic, we should. This is t squared, so there should be a t here and a t here. This is negative and this is positive, so there should be a negative there and a negative there. We need two numbers that multiply together to give us 36 and add together to give us negative 37. What are they? Okay, 36 and 1, right? So 36 and negative 36 and negative 1 gets negative 37. And 36 times, negative 36 times negative 1, 36. So this gives us two solutions for t. T minus 36 is equal to 0, and t minus 1 is equal to 0. So here, adding 36 to both sides, we get t is equal to 36. And then adding 1 to both sides, this one gives us t is equal to 1. And it's tempting to try and just look at this and box your answer, okay? But the question isn't asking us for t, it's instead asking us for x. So let me move these up to the top up here, and we'll continue on with the problem. The first one tells us t is equal to 36, and the second one is t is equal to 1. And you'll notice that I'm working in orange because I've done the substitution. I went from x to t's, and now I'm going to come back to x. Okay, what is t? It's x squared. So this first equation is x squared is equal to 36. And the second equation is x squared is equal to 1. Now, to solve for x in the first one, we take the square root of both sides. And remember that we get a plus or minus. And the second one, we take the square root of both sides. And again, remember that we get a plus or minus. So we get 4 solutions. And in this case, the square root of 36 is just 6. So we'll get positive 6, negative 6. The square root of 1 is just 1. So we'll get positive 1 and negative 1. And those are the 4 solutions to this 4th degree polynomial. And again, what you're going to do for 8, 9, and 10 are substitutions. It's not part of the learning objectives, but again, those of you going on to calculus will see this happening over again, okay? The main things you want to focus on today are the rational exponents and the absolute value. Next time around, we'll talk about inequalities. I'll be around for the next 5 minutes or so if you guys have any questions about the class, you can stick around and ask them. Otherwise, I'm going to stop the recording. Thanks for being here, guys, and have a nice day.